guys, and welcome back to erbsclass, man, for 5 more minutes of math. So we started this conversation already about solving quadratics, and you know what? Quick review. Okay, here I got a quadratic equation up here, and if I were to graph this equation, it would be a parabola, right? And that parabola will be somewhere on my graph, and if I wanted to know where that parabola crosses the x-axis, then I would just change this y value into a 0. Exactly right, because remember, that's the y value at the x-intercept. Yeah, so if I make that y equal to 0, I can solve this for x and find out where it crosses the x-axis. Yeah, so also, if this was already set up as an equation, maybe something like this, yeah, then I can solve this for x using those square root strategies that we talked about before. Yeah, but now that square root strategy can't be used all the time. Let me show you what I mean. Yeah, what if my equation is in standard form? What if my quadratic equation or equation for my parabola looks like this, right? So I will do what I did before, right? At the x-intercepts, what's the y value equal to? 0. Yeah, exactly right. But I can't use those square roots to solve for this situation. Yeah, I can only use that square root method if this x squared is the only x involved, or maybe I have a quantity to the second power that I can undo with a square root, but I can't solve this using that square root method. So, of course, Mr. Herb got another method for you. Let's talk. Yes, I can solve this by factoring. And so what I mean by that is, you remember the factoring videos about how we took this trinomial and factored it into two smaller binomials that are multiplied by each other, equivalent expressions? Yeah, watch those videos. So if I can turn this into the two factors, then I can set the factors equal to 0 because, let me show you. Okay, good. I went ahead and factored that. Now, these are equivalent expressions. These two things mean exactly the same thing, but now it's split into the product of these two smaller expressions, right? So if I multiply two things together and the result is 0, can't either one of them be 0 to make this true? Yeah. So let's set this factor equal to 0, and let's set this factor equal to 0, so we can figure out which x values would make that 0 and make this true. Like this. Yes, just like that. So let's talk about what happened here, right? So x equals -3. That is one of my solutions, and it's a solution because if I put -3 right here, what's -3 plus 3? 0, and 0 times anything is 0. Okay, so -3 works. What about -10? Now, if I put it here, it's not 0, but when I put it here, it is 0. Two solutions, and a lot of parabolas cross the x-axis twice right here at these 2 points. Okay, now let's summarize and talk about these steps while we do another one. Ooh, okay, now this one looks a little bit different than the last one. The last one had y equals, it was the equation of a parabola in standard form. Now, if you are given the equation of a line in the form y equals, set that y equal to 0, solve for x just like we talked about. Now, if you're given an equation that's jumbled up a little bit like this with no y, and it just says solve this quadratic, we're going to make sure we take care of that first step. Remember when we had our equation equal to 0? That's going to be our same first step here. Make our equation equal to 0. Now, I know that sounds crazy, like how it's not equal to 0, it's equal to 5. How am I just going to make it equal to 0? Can I move this 5 off of the right side of the equal sign and move it over here to the left to join everything else? And if I take this 5 and move it over here, what's going to be left on the other side? Yes, exactly right. I can move that 5 over here. I mean, think about it as subtracting 5 from both sides. Yeah, just like that. Now, when I subtract 5 from this side, there's nothing to combine it with, so I just add it in the line. Here's my equation. Now it's equal to 0, and now I'm ready for step 2. Good. That's a real quick AC method. If you need that, go back and watch that video. Now the last step. Set the factors equal to 0. Looks like this. Good. Now, these two places are where this graph would cross the x-axis. These two values of x, if I put either one in here, this will be equal to 0. Those are our solutions. Yeah. Man, I hope this helps. If it didn't, practice will. I'll see you there. Bye, guys.